All right, guys. Well, it is the week of May 19th through the 23rd. All right. And so we got 1, 2, 3, 4, just 4. Okay. And then, yeah, I got, might have to put some more assignments here just so you have something to do during that week. But wow. Let's get to it. So we're going to talk about square roots, cube roots, surface area, and a little bit of statistics of box plots, interquartile range, and it should be a lot of fun. All right, so let's start with square roots and cube roots. Okay, so we talked about these before, so this is a little bit of review. Okay, so if you have m squared equals 81, then you should be thinking back to your perfect square list. So let's just make that real quick. Our perfect square list would be 1, 4, 9, 16, 25, 36, 49, 64. This is all the numbers squared. 121, 144, 169, 196, 225, 296, 343, and then I lost. Okay. And yeah. Okay, so that's pretty good. 17. I usually go up to 15. All right, so 81 is 9 squared. So it's going to be 9 or negative 9 times negative 9. It's also positive 80. Which equation is true when x equals 3, but not when x equals negative 3. So this is our, when we have squares, so for squares, a negative times a negative is a positive, right? So that for that reason, x squared equals 4, x could equal 2 or negative 2. But cubes, 3 negatives is not a positive. So if x cubed is 27, then x equals 3, but not negative 3, because 3 negative 3s would be negative 27. So which equation is true for 3 but not negative 3? That would be a cubed. And let's see. So is that going to be x cubed equals 27? All right, select all the rational numbers. So that would be any perfect squares or perfect cubes. So let's make a perfect cube list. And the cubes are, I'm just going to go up to 10. 1, 8, 27, 64, 125, 216, 343, 8 cubed is 512, 9 cubed is 729, and 10 cubed is 1,000. Okay. So rational numbers, that's 2, that's 2 as well, and that's 4. All right. So yeah, go ahead. You do that one. So that's a little bit of the squares and cubes. Should be fun for you. Now let's talk about surface area. So we talked about volume earlier in the year, and volume is the amount of unit cubes you can fit in a shape. And we have volume formulas, but now we're going to talk about surface area, which is the wrapping paper that you could put around a shape. So what you want to do is you want to think about all the surfaces of this shape. So now look at this box. We have a front and a back. We have a left side and a right side. And we have a top and a bottom. Now you could also unfold it and think of it as a net. But this and this is actually a cube, right? So everything is the same. The front and the back are both 3 times 3, which is 9. And then if you multiply that by 2, because we have a front and a back, that's 18. And then the left and the right side is the same thing. So we have 3 18s. So that's going to be 2, 3, 4, 5, 54. So if you add the front, back, left, right, top, and bottom, I think you get 54. And then the same thing here. Okay, so cubes per, okay, we gotta do this one again. So then there's gonna be 9 times 9 is 81. So we got 81. We got 6 faces of 81. So that's gonna be 486. 486. All right. Now here we have a triangular pyramid. But we're still thinking about the different faces. So the bottom is a triangle that has a base of 9 and a height of 7.8. So the bottom is 1/2 base times height. And then the sides, so this side right here is 9 times, and then the height is 8. So the side is 1/2, base is 9 again, but the height is 8. And I think that's going to be true for all 3 sides. So we can take whatever we get here and multiply it by 3 because there's 3 sides. I think, yeah. So if I'm looking as 9, 9, 9. So it's an equilateral triangle. Okay, so then this is 72, and then half of 72 is 36. So it's 36 times 3. Going to be 18, 3 times 3, 108. And then, I don't know, 7.8 times 9. 7.8 times 9 divided by 2. It's 35.1. So this, oh, 1 second. Okay, so that, now see, I forgot already. Okay, 35.1. So the base is 35.1. The sides add up to 108. So then let's just add 108 to that. We get 143.1. 143. Keep it up. All right, so there you go. So whatever shape it is, think about the top, the bottom, the sides, and what their areas are. You know, we know squares, rectangles, triangles, circles, and so that shouldn't be too bad. But then we, yeah, so then here, we have a circle for the top and the bottom. And then what is the shape? If you unfold a cylinder, what do you think the shape would be around the side? Well, you can actually do that. You could take like take a paper towel roll as a cylinder, and then if you cut it and unfold it, you will find it's a rectangle. Okay, so I'm just going to make this into a nice little formula for you. So the surface area, surface area of a cylinder, we have a top and a bottom, and they're both circles, which is pi r squared. And there's 2 of them, so it's 2 pi r squared. And then the rectangle, so the side folds out into a rectangle, and the bottom of the rectangle is the circumference of the circle. And we know the circumference formula of a circle is 2 pi r. And then this side is the height of the cylinder. So it's going to be h. So it's 2 pi r h. And so the cylinders are a little bit nicer than the other shapes because we have a formula. And if you know the height and the radius, then you just substitute them in. So here the radius is 2, the height is 3. So I'm going to use my formula here, but for r, I'm going to put 2, and h, I'm going to put 3. So 2 pi times 2 squared, 2 squared, plus 2 pi times 2 times h is 3. So this is 6 times 2 is 12. I'm going to leave the pi in as long as I can. So that's 4 times 2 is 8. So I have 8 pi plus 12 pi is 20 pi. And it says to round to the nearest hundredth. So now I'm going to do 20 times 3.14. And that is 62.8. 62.8 meters squared. Okay. So let's verify. There. Okay, so that shouldn't be any harder than that. The only thing they could do to make it a little bit more difficult is give you the surface area and ask you to find the radius or the height, which would just be solving an equation. All right, now let's talk about box plots and interquartile ranges. Last week we talked about ranges, right? So the range is high minus low, or more precisely, the max minus the min, right? The interquartile range, which we call the IQR, interquartile range, is going to be Q3 minus Q1. So instead of the max minus the min, it's these middle max and mins. We might be saying, what is Q3 and Q1? So in a box plot, it's a way to represent data in a visualization. So our minimum goes at the bottom of the left whisker. Our maximum goes at the top. Our median is the line in the middle. And then the median of the lower half of the data is called Q1. And the median of the upper half is called Q3. So the actual median you could think of as Q2. And so the box plot isn't always symmetrical like this, but what it is true is the whisker is the lowest 25% of the data. The first part of the box is the next 25%, another 25% for the top half of the box, and then 25% for the upper whisker. So each one is a quarter of the data. So then, you can really get a sense of what your data looks like. And then we can do our statistical measures and then compare data sets. So how do we get the lower quartile? So like I said, the lower quartile, Q1, is the lower median. And okay, so we're just going to find a bunch of medians. So do we have the data in order? We do. So the first thing is making sure the data is in order. And then we're going to find the medians. So we find the first median, the actual middle number, by just going 1, 2, 3, 4. And then the median is going to be in between 51 and 57. So we add those together and divide by 2 to get the median. So it's going to be 108 divided by 2, which is 54. So the median is 54. Okay. So that's the median. So then this is the bottom half of the data, and this is the top half of the data. So in the bottom half of the data, what's the middle number? It is 50. So that's our Q1. And in the top half of the data, it is 73. We only have 3 numbers. So that's how you do that. We're just finding medians. 50, 54, and 73. Well done. Okay, so go ahead and try that one. Find your medians. And now let's talk about, now, yeah, okay. And then if it asks you for the interquartile range, let's just say, one more time, if it says, what's the interquartile range? Once you find the lower quartile and the upper quartile, that's Q1 and Q3, then the interquartile range again is just Q3 minus Q1, just subtracting. All right. Last one. Look at this, not a 25-minute video. Isn't that good? All right. So now we're just interpreting a box plot, which I already gave you all the different parts. Let me just write it one more time so I can refer back to it. All right, so we have our min is right down there, then going to Q1, the first half of the box. In the middle, or the line inside the box, is the median. Q3 is up there, and the max is right there. So let's see if we can answer all our questions. What's the median? What's the line in the box? 7. Was the median is 30. It's the line in the box. Was the range? Okay, we know that's max minus min. So that's going to be 350 minus 50, or minus 125. This would be 125. This is 350. So 350 minus 125 is 2, and then 225. One more. Median, goodness, just keep asking me for the median. And what's the highest temperature? 68. You're gonna do fine on this. Hey, oh no, forgot to sign it, but that's okay. All right, so go ahead, get 80s on all these, or at least as high as you can. And then if you want, you can even get ahead. I mean, you know, if you finish early this week and you get a head start on the last 3 weeks of assignments, it can make life easier for yourself as we get into June if you already have scores on these things. So keep that in mind, because if you're tired now, you're only going to get more tired. All right, I will see you in class.